Hello and welcome to Water Quality. In this video I'm going to go over an example that's a continuation of a previous example, so make sure that you watch that one first. So here we still have the drinking water treatment plant that's adding sodium hydroxide to raise the pH from 6.8 to 7.6. And they need to do that so that the water is not corrosive in the distribution system. And so we know that the sodium hydroxide concentrated solution that they're going to add has a concentration of 17 moles per liter. And we want to know what's the flow rate that we have to provide if the plant is going to produce 50 million gallons per day of drinking water. So that's a pretty big plant. Okay, so I'm going to draw a schematic. So this is my drinking water. And we have a flow of 50 times 10 to the 6 gallons per day. And then we're adding this concentrated sodium hydroxide solution, 17 moles per liter, and we want to know what the flow rate is. And we have a target sodium or sodium hydroxide concentration that we solved for in the last video, and that is 10 to the minus 3.59 molar. So one of the assumptions here is that the flow rate in the plant does not change appreciably as the result of the addition of the sodium hydroxide solution. So this is so concentrated that the impact on the flow rate is going to be negligible. And so we can write this really simply as a result of that assumption, where I'm going to use this equation here, dm dt, which is equal to concentration times flow. So when I multiply a concentration times a flow together, I get a mass rate. And the mass in this problem is conserved, so the amount of sodium added with the solution is going to be equal to how much solution is in the final effluent, the produced water. Okay, so that means that my concentration NaOH times my flow rate of the NaOH is going to be equal to the concentration of the drinking water, I'm just going to call it W, times the flow rate of the drinking water. And I'm assuming that the flow rate is relatively unchanged by this addition. So for my concentration of the finished water, I have 10 to the minus 3.59. And then my flow rate is 50 times 10 to the 6 gallons per day. Solving for this, and then my concentration is 17 moles per liter. Now the nice thing here is that I have some of my units are English and some of them are metric, but it doesn't matter as long as my C units are all the same and as long as my Q units are all the same. So then I can solve for the flow rate and I get 756 gallons per day, and that's my answer.